Now, in the last video where I showed you how to make no-clip detection script, I made a couple of embarrassing mistakes in that script. So in this part of the video, I'm showing you how to fix these mistakes. But now what I'm going to do is make the script that will allow us to test our teleportation detection script. The way the teleport script is going to work is when you press T on your keyboard, it will set the value of a certain variable to true. And then when the value of that certain variable is true, and then you click on your screen, it will teleport you to the location in the world of where you clicked on your screen. Now, if you press T while the value of that variable is equal to true, then it will set it to false. And while that value is false, it will not allow you to teleport. Obviously, you would not want to have this script in your game because it would allow players to teleport. This script is simply to test the anti-cheat. The reason that I am offsetting the C-frame that we're teleporting the player to by a certain amount is because if we teleport them to the exact location where they clicked, part of their character will be clipping through the surface that the raycast hit, and that would trip the anti-cheat at a time that we don't want to. And you can see this when I write tpcf colon point to world space negative tpcf dot look vector times 5. Eventually, though, I actually changed this to the surface normal rather than the tpcf dot look vector. The way that the teleportation detection script will work is every frame will cast a ray from the player's current position to the player's last position. If that ray hits something, then we are pretty confident that they are teleporting. Now, we're also going to add a bit of lag detection too, because if the player is lagging, then it may seem to the server that they are teleporting, but in reality, they aren't teleporting. So if they are lagging, we will not check to see if the player is teleporting or not. Now, the way that we're going to detect whether or not the player's lagging is when they stop moving, we can assume that they are lagging. Now, if the player stops moving, it also means that the teleportation detection script will think that they're lagging. And a way that player could exploit this vulnerability is they could just stop walking or stop moving and then click to teleport, really just teleport to some location. So what we're going to do is if player somehow manages to move past another side of a wall, what we will do is we will check to see if they would have been able to move to that location in the amount of time that they were lagging. So if it would have normally taken them 5 seconds to walk to that location and they teleported there within a time span of roughly around 5 seconds, and we can be certain that they just lagged and they actually walked to that location. But if they teleported to that location within a fraction of a second and it would have normally taken them 5 seconds to get there, then we can be confident that they are hacking. Now, you need to be careful when you do this because I haven't tested this thoroughly enough to know how effective this works and what the false positive rate is on this specific method of detecting teleporters. So this might not work very well on very large and complex maps. So if you don't want to do this, then don't run the function action check. Now, here what I'm doing is telling the anti-cheat what the maximum walk speed is in studs per second for each player. If your game has some type of shift to sprint mechanic or something similar, you would need to set this value to the maximum possible speed that the player can walk. So if sprinting makes you walk at a speed of 20 studs per second, for example, then you would need to set this value to 20. What I'm doing now is making the speed hack detection script. The way that this script will work is every second the server will check the distance between the player's current position and the player's last position. If this distance is greater than the player's walk speed plus 2, then it will subtract that distance divided by the player's walk speed plus 2 from something called the lag det, which I will explain in a minute. The reason that I am using the player's walk speed plus 2 instead of just the player's walk speed is because the math that calculates the distance between the player's current position and the player's last position isn't very accurate, and if the player is walking at 16 studs per second, the script might think that the player's walking at 16 studs per second, give or take 2 studs. I've done enough testing to know this. This is also the reason why I check the distance between the player's current position and last position roughly every second instead of every frame, because it seems to be more accurate this way. The speed hack detection will also have its own method for detecting lag. If the player stops moving and then the player starts to move again, it will calculate how long the player was not moving and add that to the lag det value. If the player is constantly speed hacking or moving around too quickly, then what can happen is the lag det will become negative and the health of the player's humanoid will be set to 0. Now what I have decided to do here is change the maximum walk speed value, which is a variable stored in the teleportation detection script, to an attribute inside of server-script service. This is so when you make changes that could affect the maximum speed of the player, like adding a shift to sprint mechanic, you don't need to make changes to each script that needs to know the maximum speed of the player. Instead, you just change one value that is stored in server-script service. Here I accidentally added an unneeded value to the player table in the teleportation detection script, so I am just commenting out the code that does this. Here I forgot to set last position to playerTable.lag position.